Let's continue with race 2 of the Secureum Bootcamp. This time we will look at both the question 4 and 5. So the question 4 is all about access control. Access control means we check the message sender, so the caller of a function, whether this message sender is actually someone who should be allowed to make the call to this function. So it says access control on message sender for DAO membership is required in. We have three functions mentioned here. One is create vote, the other is cast vote, and then get winning outcome. Let's look at those functions real quick. We have here create vote, and we can see that it is an external function, and currently it only has the only when open modifier and the when not paused modifier. So currently there's nothing preventing non-members from calling this function. And the same is true for the cast vote function. The only difference here is that it also has a vote exists modifier, which apparently makes sure that there is something to vote for with the specified vote ID. But otherwise, this too can be called by anyone, even non-members. Would it make sense to have a DAO where people who are not members of the DAO can vote? I mean, that's kind of the whole point of a DAO, that only people who are members can make decisions on something. So maybe there are cases like that, but in this specific case, in a typical case, probably not. And the third function that was mentioned in the question was the get winning outcome function. And this one is a public view function. So it's a read-only function. So going back to question 4, so it was about which of these require access control on message sender. And it says here with 4a that create vote should have access control to prevent non-members from creating votes, and cast vote should also have access control to prevent non-members from casting votes. And I think both of these are reasonable. Next, we have C, and it says here that get winning outcome, which was the view function, so it's read only. This should also have access control to prevent non-members from viewing winning outcomes. And this doesn't really make sense, because even though this is a cryptocurrency, there's actually nothing encrypted in terms of the balances or the state in this blockchain. So even if you prevent other contracts from calling the get winning outcome functions, you would still be able to read the winning outcomes directly out of the blockchain state. So try as hard as you want, but you can't really hide the winning outcome like this with access control, at least. It's just not possible. So C doesn't make sense. And that was question number 4. Now moving on to question 5. It says here that a commit reveal scheme, a cryptographic primitive that allows one to commit a chosen value while keeping it hidden from others, with the ability to reveal the committed value later, is relevant for. So we already talked about commitments, commit and reveal once, but very short and quick. Basically, you have some secret. Let's say we have some secret seek, and we have some blinding factor. And we need the blinding factor so that someone can't just guess the secrets, because what we're going to do with both of these, we're going to hash them. And this hash will be our commitment. So basically a commit reveal scheme. In a commit reveal scheme, the user doesn't immediately send his secret. Instead, what he sends is this hash of the secret and the blinding factor. And this hash is also called the commitment. So he sends the commitment, and later, when everything is done and it is time to reveal what you have committed, then he will prove that his commitment was actually for this secret. And to reveal, he also has to announce the blinding factor. With hashes, if we would only use the secret, then, and the secret is very short, then it is very likely that people can just keep brute forcing, keep guessing until they find out our secret, and therefore what we committed to, we don't want that, so therefore we want a blinding factor. So that, in short, is what we can do with a commit reveal scheme. And here this question basically asks in which parts of this DAO, of this decentralized autonomous organization contract, where does it make sense to use a commit and reveal scheme to improve the security? So we have A, and it says here that the join function, so the function which people can use to join the DAO, we can add a commit reveal scheme to not disclose the message sender while joining the DAO. So this doesn't really make sense because you can't really commit reveal a message sender, because if you're calling the function, the commitment would be part of the call data that you're sending to the function, but the message sender, you as the caller, the address, is outside of this call data. It's something that is always available. So maybe you can get some third party to call that function for you. That could work. Some other function calls this function for you, and it sends this commitment for you instead. And later you will yourself reveal it was actually me who wanted to join this DAO, and I can prove that it was me because only I know this blinding factor that was used to create this commitment. You could do that to hide the fact that you wanted to join, but what would be the point really? At least in this DAO, there is no point in hiding yourself from joining the DAO. There is no disadvantage you get, or at least no immediately visible disadvantage you have from announcing publicly that you will join the DAO. So A still doesn't make sense, even though it would be possible in some way by using a third party as a relay basically to send your transaction. Now we have B, which says that create vote to not disclose the possible outcomes during creation. So the possible outcomes of a vote are basically what people are supposed to vote on. Should we change something? Yes, no. So if you make commitments for yes and no, and you don't know which one of these is yes and which one of these is no, how are people supposed to vote for it if you keep it secret until after the vote? So people voted for they don't know what, and then you reveal this is what you actually voted for. So no, that doesn't really make sense to do a commit reveal scheme here either, except for maybe some really edge case scenario that I can't come up with right now. But no, B doesn't sound like it makes sense either. And then next we have C, which says that cast vote could use a commit and reveal scheme to not disclose the vote being cast. And in this case it makes sense, because there is some time between the creation of the vote and when the vote ends and people no longer can vote, and then the result of the vote is like hammered in stone. It can no longer be changed. And maybe for political reasons, for safety reasons or whatever, you don't want to reveal the votes until the votes cannot be changed anymore. For example, as an example scenario, maybe there is a person who has a lot of tokens to vote with, to cast vote with, and they didn't bother voting so far because they didn't mind the result so far. But suddenly someone else with a lot of tokens votes, and that person doesn't like the way they voted. So now they can say, wait, I'm gonna vote too, and I'm gonna vote more than him. Or maybe even, this actually sounds like something that sounds fair, but let's go with maybe with another scenario where people buy votes from each other, basically. maybe someone is selling their votes to someone else to do this manipulation, to prevent this result that they don't like from happening. So for scenarios like this, it might be useful to actually hide what is being voted or what people have voted for until the point when the vote is over with and until the point when the result can no longer be changed. Arguably, not everyone would like to have this feature. This transparency in this voting might actually be a desired functionality, but maybe not for everyone. But definitely you can use a commit and reveal scheme here, and it is definitely relevant for cast vote to not disclose the vote being cast. So I would say that C is the one that makes most sense and is correct in terms of question 5.